If the goal is hypertrophy, then the goal should actually be more specifically to accumulate contractile proteins within the muscle. This, of course, was representing an increase in the actin and myosin content within the muscle. This is termed true hypertrophy. It is not transient hypertrophy. But what we have to appreciate is that within our muscle cells, we are constantly building protein, but we are also constantly breaking down protein. Obviously, if we want to accumulate contractile proteins, we must have protein building or protein synthesis happening at a much faster rate than protein breakdown, right? At the end of 24 hours, you need to be in a net positive protein balance, meaning these pathways must work very, very, very quickly. And that's what we're doing with training. We're using the training stimulus, what you do in the actual training session, to stimulate an increase in the speed of these biochemical pathways. These biochemical pathways ultimately lead to the building of protein. So if you can speed them up, then you can accumulate protein over time. We also use nutrition, and that's why, of course, protein intake is highly related to hypertrophy and things like that, because the protein we ingest is also used to help speed up the protein building pathway. And if you can do this consistently over time, then you're slowly accumulating contractile proteins in your muscle, and the muscle will grow over time. The hypertrophy stimulus requires mechanical tension. Remember that by the hypertrophy stimulus, what I'm really referring to is the increase in the rate of protein synthesis within muscle cells. That is what is being represented by the hypertrophic stimulus. Remember, to have hypertrophy occur, we need protein building to happen much faster within our muscle cells. So what are the triggers? What are the factors that can initiate an increase in the speed of protein synthesis within muscle cells? That's what we're seeing in the image here. At the bottom of this cascade of events is protein synthesis. So what we're seeing are some factors here. In particular, it is mechanical stress. Mechanical stress is what we can do in the gym, in training sessions, to initiate the increase in protein synthesis. Now, how do we get this mechanical stress? Well, it refers to the overload principle. Provided you have reached enough overload, okay, proximity to failure, you will have supplied the requisite mechanical tension to initiate an increase in protein synthesis. This mechanical tension specifically is sensed by mechanoreceptors. These are receptors within the muscle cell that respond to mechanical type of stimuli. And this is a mechanical stress, right? And so this mechanical tension or mechanical stress leads to an increase in the rate at which protein is built within muscle cells. Again, if you can do this consistently over time, it should result in an increase in muscle size. The table on the left, and specifically this row on hypertrophy training. Now, the recommended rep range for developing hypertrophy is anywhere from 5 to 30 reps. Now, this would correspond to a load of about 30% of the 1RM all the way up to maybe 80% of the 1RM. And this is a very, very wide recommendation for reps. But the reality is the body of evidence supports that low rep and high rep training yield similar results when it comes to hypertrophy. That's what you're seeing on the right-hand side. This is a summary of various studies that compared high repetition or to low repetition training. Another way of looking at low versus high rep is low load training, obviously high reps, or high load training, which is obviously lower reps. So this might represent, let's say, sets of 20 over here, and this might represent, let's say, sets of 8 or 10 on average over here. Now, how we read this chart is it's looking at, was there any differences in hypertrophy between groups that had done high rep or low rep? And that's what these individual citations are representing. So this is really a summary of multiple studies that compared high rep training to low rep training. And what you see is a large cluster of data all around the kind of midway point here. Now, if all of the dots would have fallen on the right-hand side of the midline, that means that, yeah, 8 reps and higher loads were better for hypertrophy. If most of the dots had fallen on the left side, that would suggest that no, we get better hypertrophy from lighter loads and higher reps. But as you can see, there's a cluster, and it clusters kind of around that center line because there really doesn't seem to be much of a difference. This makes sense if we look at the mechanism behind hypertrophy. For hypertrophy to take place, we need an increase in the rate of protein synthesis or protein building in the muscle cell. And the primary trigger for that is mechanical tension. So provided you come close to failure or you apply enough mechanical tension, it doesn't matter if you apply that mechanical tension doing 5 reps or doing 25 reps or 30 reps. The point is you are supplying enough mechanical tension to increase the rate of protein synthesis within muscle cells. Again, done consistently, it should lead to an increase in hypertrophy.